Welcome to Civil Engineering YouTube channel. Today I will show you two very important things that structural engineers must know on Autodesk Robot Structural Analysis software. The first point is that how to define and design loads, that is both vertical and horizontal load. In case of horizontal load, that may be dead load or live load. But in case of vertical loads, that may be wind load, earthquake load, lateral soil earth pressure. The second point that I'm going to show is how to create load combination for both static and dynamic analysis into video parts using this model that we have to create in tutorial part 1. If you have interest on how to create modeling of this project, check the link in the description box and first comment of this video. Watch this video up to the end to master structural design. Now it's a time for subscribe my channel to get daily update tutorials free. Thank you. Let's dive into this practical tutorial. As an engineer, you have to identify all possible loads applied on this project or on your structure. That may be a dead load, live load, a wind load, lateral soil pressure, or earthquake loads. So using this load, we are going to define and assign such load on this project that we are going to model in tutorial part 1. First of all, it's better to define the self-weights of this model. So to do this, it's better to go to load types here. After that, make it the number as 1. So the nature of this load type is dead. And the sum nature of the self-weights of this model is structural. So after that, I have to make the name as self-weight. Yes. Make it self-weight. Right click here, copy. After that, make it the label also self-weight. After that, make it that. So the self-weights of this project is defined like this. So the software itself calculates all the value of self-weights of this load as a dead load. So close it. After that, go to load table. From here, the self-weights of this project is defined like this. Make it close and define other load types. Go to load type. Here, I'm going to define the partition wall load. So to do this, make it the number 2. After that, the nature of a partition wall load is a dead load. And its sub-nature is not structural. It's non-structural. Make it non-structural. That is because partition wall load is not a load bearing. So make it non-structural. After that, make it a partition wall load. Yes, copy this value to the label here. So make it that. Partition wall load is defined like this. After defining self-weight and partition wall load, it's better to go to define the floor finish loads. So make it the number as 3 and floor finish load is a dead load and its sum nature is non-structural. After that, make it a floor finish. So copy this name as a label also. So make it that. Partition wall load is defined like this. After defining the dead loads, that is self-weight, partition wall load and floor finish load, it's better to go to define a live load. So to do this, first make it the number as 4. After that, make it the nature of the load as live. From this, Eurocode recommends or Eurocode defines a lot of category of live load, that is from category A up to category H. From this category, category A is for residential building and category B is for office and etc. and that of category H for a roof. So you can refer your building code of standard from this. So our project is a residential building. So I'm going to define a live load that is for category A. So after that, make it live. Yes, make it live. After that, I'm going to copy this live as a label. Make it add. So the live load with category is defined like this. After that, I'm going to define a live load for the water tanker at the top of our model. So for this, I'm going to define live for a water tanker. After that, make it the category A, and the only difference is the value of live load. So make it that. After defining dead end live load, it's better to go to define other loaders, that is the horizontal load, that may be a wind load, earthquake, or lateral soil pressure. So to define this load, it's better to go to add the number as 6. After that, make it the load as wind. After that, I will make it wind. After copy this value as level, copy paste. After that, make it add. After defining the wind load, it's better to go to define earthquake loads. So make it seismic. After that, make it earthquake here. It may be in X and Y direction, so make it earthquake. After that, I have to differentiate letter. I will show this in load combination section. So copy this and make it as a level, yes. So all the possible loads are defined like this. After that, make it close. Go back to your load table. There is no any load here except the self weights of the model. This is because after assigning all the loads to your model, you will get all these value that we are going to define. I will show it later. So first of all, it's better to go to assign the partition wall load on beams or on members. To assign loads on the member and the panel, first of all, I have to select here that partition wall load. This is because the self weights of the project or the model is calculated the software by itself. So I have to select partition wall load to assign on both the member and the panel itself. So to do this, I have to go to load definition. After that, select a member. So make it a distributed load. After that, look at the Z direction, that is it's in upward direction. To assign the load the opposite of Z direction, you have to make it a negative. So I have to assign a negative 12 kilonewton per meter load to this member. So to do this, make it add. But before this, I have to go to this member selection menu. From this, I have to select all the sections except the top level, that is the water tanker, that is beam select by section, that is beam 400 by 250. After that, click on here. So all the beam is selected. Make it close. After that, have to select apply to here. Click here. After that, make it apply. So all the distributed load is applied like this. But for water tanker, go to load definitions also. So make it a member distributed. After that, I have to decrease this load as 4. This is because for parapet wall only. After that, make it add. But before this, I have to select a member selection only. After that, I have to select the beam for partition wall load. The beam for a water tanker, that is 400 by 200. Make it select here. Close. I have to make it add. Click on here, apply. The load is assigned like this. After assigning the partition wall load to the member, you have to proceed to assigning loads to the panels. Go to load definitions here. After that, I have to select a surface. surface distributed load. For a partition wall load, I have to calculate each load independently, but in our case, I'm going to assign 2.2 kilonewton per meter square load, that is equal to a kilopascal. So I have to make it add. After that, click here, submit, click here, apply. Right click here, select a similar, select by thickness. After that, have to go to load definition, make it surface, apply, add, click here, apply. All the surface load is assigned like this. Make it close. Change the load as floor finish. After that, I have to go to load definitions again. All the surface load is assigned like this, but for water tanker, I have to assign independently. But as a tutorial, I will assign all the loads. But in practical design case, I have to assign all the loads on the cantilever parts and to the water tanker part independently. So to assign the floor finish load, make it a surface here, partition wall load. So as a floor finish load, I have to assign 1.8 kilonewton per meter square, or that is equivalent to a kilopascal. So make it add. After that, click on here, apply. All the load is applied like this, but in your case, have to calculate each floor finish load at for all the panels. But in our case, as a tutorial part, I will assign like this. After that, I have to assign all the loads, that is a live load. So to do this, all the panel is selected. After that, I'm going to go to load definitions, make it surface distributed. So a live load, you can use 1.5 up to 2 kilonewton per meter square for a residential building. So for the balcony and cantilever part, you can use 4 kilonewtons. But in our case, I will apply 2 kilonewton. 2 kilonewton per meter square surface load to all the parts. So make it add, click on here, apply. So all the load is applied like this. Make it close. These were the most important parts regarding to defining and assigning all possible loads that are applied on our project. In the next tutorial part, we will see how to create load combination for both static and dynamic analysis in detailed explanation. See you there. Thank you for watching. Have a nice time.